Good morning, dear students, and welcome back to our today's online session. We are studying about nitric acid, and in our previous class we learned how to prepare nitric acid in the laboratory. Now in our today's class we are going to discuss about another method by which we can prepare nitric acid, and this method is a large-scale preparation of nitric acid, and the method is called Ostwald process. Now we all know that nitric acid is very important reagent. It is widely used in the manufacture of fertilizers. It is very widely used in the manufacture of drugs, dyes, and even perfumes. So its demand is very huge. Therefore, to meet the very huge demand, we need to produce nitric acid in large scale. And it was very difficult before First World War to manufacture nitric acid in a large scale. The very fact being the production of ammonia in large scale was very difficult and costly. It was only possible later when Haber's came up with a brilliant idea of manufacturing ammonia, and that process we all know that it is called Haber's process for the manufacture of ammonia, which we have discussed in our earlier chapter, ammonia. So with the help of this Haber's process, a large-scale preparation of large scale of ammonia was possible, and due to which the large-scale production of nitric acid was also possible later. So today we are going to discuss about large-scale preparation of nitric acid by Ostwald process. Now nitric acid, as I said earlier, it is very important reagent, and during 1914 a German chemist Ostwald, he came up with a very brilliant process of making nitric acid in a large scale, and he called this process by his name, Ostwald process, which involves 3 different steps for the manufacture of ammonia. Before going to the manufacture of ammonia by Ostwald process, let's see what we have to study according to new reduced syllabus in the manufacture of nitric acid by Ostwald process, which is highlighted by red color. So according to new reduced syllabus, you have to study manufacture of nitric acid by Ostwald process, and you have to study only equations with conditions wherever applicable. So we are going to focus on this particular syllabus, reduced syllabus. Now let us see how nitric acid is manufactured by Ostwald process. So this is the arrangement made in the factories for the large scale preparation of nitric acid. In this method, in the first step, the catalytic oxidation of ammonia is carried out. So we need ammonia, which is prepared by Haber's process, in 1 volume by ratio to 10 volume by ratio of air. So we need 2 reactants, and they are dry ammonia gas and very dry air, and this air must be dry, free from carbon dioxide and dust particles. So let's see the first step. So this first step is called catalytic oxidation of ammonia. Catalytic oxidation, here we take 2 reagents, oxygen and ammonia. Oxygen, air means oxygen. So in the first step, the ammonia, dry ammonia and dry oxygen or air is compressed and passed on to the catalytic chamber, where platinum is used as a catalyst. The reaction for this particular step is 4NH3 plus 5O2 produces 4 nitric oxide, 4 moles of nitric oxide plus 6 moles of water, and it also produces heat energy. Therefore, this particular reaction is a exothermic reaction, and this reaction is carried out at around 800 degrees Celsius using platinum as the catalyst. So you have to know three conditions over here, and those three conditions are: the reactants are dry ammonia and dry air. That is one condition. Second condition is we use platinum. We have to use platinum as catalyst. And the third condition is the temperature is maintained around 800 degrees Celsius. So when these conditions are met, in the first step we get nitric oxide along with water and evolution of heat. So this is an exothermic reaction. Here it is an exothermic reaction, and the hot gases are then passed. So this hot gases means nitric oxide and water vapor. So these gases are passed through a cooling chamber, also called the oxidation chamber, for further process. So after the completion of step 1, the hot gases are now passed to the oxidation chamber for second stage of reaction. Let us now see the second stage of reaction. Now in the second step, we do the oxidation of nitric oxide in the oxidation chamber. So this is the oxidation chamber. So in this oxidation process, the nitric oxide, which is produced in the first step, is further oxidized at around 50 degrees Celsius to produce nitrogen dioxide gas. So this is the chemical equation to represent the reaction, oxidation reaction taking place in the oxidizing chamber. And in this second step, the oxidation of nitric oxide, oxygen is used as the oxidizing agent over here. Now once the nitrogen dioxide is prepared in the oxidizing chamber, this nitrogen dioxide with the remaining air is then again now passed through another chamber, which is called absorption tower, which is filled with quartz stone packed in layers. Now on this quartz tower, warm water is sprinkled so that the nitrogen dioxide, the air and the water, warm water, they all react with each other to finally produce nitric acid. And this nitric acid produced is aqueous in nature. It is mixed with water. So let's see the step 3. This step 3 is known as absorption of nitrogen dioxide in water. The reaction is nitrogen dioxide, which is a gas, reacts with water, which is liquid sprinkled from the tap, and the oxygen gas, which is the remaining air, reacts together to form nitric acid. The acid which we get over here is the aqueous solution, since water is mixed with it. Now after the completion of third step, we get nitric acid, which we desired to produce. Now this nitric acid obtained is about 50% concentrated, which can be further concentrated by distillation up to 68%. Now by the distillation of aqueous nitric acid, we can only get 68% of concentrated nitric acid. This is because when the aqueous solution of nitric acid is heated, it forms a constant boiling point at around 121 degrees Celsius. Therefore, we cannot concentrate or increase the concentration of nitric acid above 68% due to the formation of constant boiling mixture. Now, the concentration of nitric acid can be increased above 68% by distilling 68% nitric acid over concentrated sulfuric acid, and we all know concentrated sulfuric acid acts as a drying agent. Therefore, when 68% nitric acid is distilled over concentrated sulfuric acid, we get nitric acid up to 98%, which is also called fuming nitric acid. So fuming nitric acid is nothing but it is a 98% concentrated nitric acid. So this is how we get a concentrated nitric acid by Ostwald process. I'll again revise it. The reactants used in this method are ammonia and oxygen, which is air, in the ratio 1:10 by volume. The catalyst used in this step 1 is platinum, and the temperature maintained is around 800 degrees Celsius. It is a highly exothermic reaction, so the heat produced will continue the further reaction. In the step 2, the nitric oxide produced is further oxidized by using oxygen at around 50 degrees Celsius to nitrogen dioxide gas. The nitrogen dioxide gas, along with the presence of oxygen and the addition of water in the absorption tower, is then finally converted into nitric acid. The nitric acid obtained after step 3 is 50% concentrated, which can be further increased up to 68% by distillation process. We cannot increase the concentration of nitric acid beyond 68% by distilling aqueous nitric acid solution, due to the fact that it produces a constant boiling mixture at around 121 degrees Celsius. Therefore, the concentration is increased by distilling 68% nitric acid over concentrated sulfuric acid, after which we can get 68% concentrated nitric acid, and this 68% concentrated nitric acid is also called fuming nitric acid. I hope I have made you understand this manufacture of nitric acid by Ostwald process. So based on today's learning, there is an assignment for you, assignment number 8, which you have to complete and send it to me. Now we have to, in our next class, we will study about the oxidizing nature of nitric acid, which is the reduced syllabus according to new rules. Therefore, I want you to go through your book also for detailed reference, okay, and complete your assignment and send it on time. Until we meet next time, stay safe and do all things well.